Hello everyone. In this video, we are going to see the topic on DAG representation of basic blocks in compiler design. So what is a DAG means? It is a directed acyclic graph. So the DAG versus the other intermediate representations. So DAG is a intermediate representation of the three address code that could be used in that code optimization phase. So we have several intermediate representations like parse tree and abstract syntax tree and also the directed acyclic graphs. So what is the difference between these three are? In the parse tree, it is also the hierarchical structures that represents the syntax, but it includes the redundant expressions and it leads to the larger representations of variables. Next is an abstract syntax tree, that is an AST. That parse tree is used in that semantic phase, but still it maintains the separate nodes for the identical representations. So next is the DAG. It is a directed acyclic graph that is merge the identical sub-expressions into the single expressions and providing the most compact and optimized representation of the basic blocks. So in the directed acyclic graph, we are combine or merge the identical representation is a single representation. Because of that, the code is reduced and it improves the efficiency. So that provides a optimized code in the particular program. So DAG is used for improve the program efficiency and also reduce the code, and it find the redundant code and the dead code. So this is the main optimization method are used in that optimization phase. Next is why the DAG is very important in compiler design means using DAG we can eliminate the sub-expression. So we can detect the what are all the sub-expression in the given code, and that sub-expression could be eliminated in terms of using that graph structure. Next is that it reveals the optimizations. It represents the intermediate code in a way that exposes the optimization that could be hidden in the original source. So it reveals the optimization, and also it tracks the dependencies. So it monitor the variable usage and which variable is an alive, which one is a dead. So these track is maintained in terms of using that DAG. So the suppose you that particular variable is not alive means that is a dead variable means we can eliminate the dead variable to improve the efficiency. So that is why the DAG is very important in the compiler design phase. Now we will see how to construct the directed acyclic graph. There is a procedure for constructing the directed acyclic graphs for the particular basic block. We have first one is leaves are labeled by the unique identifiers, either the variables or the constants. So the leaf nodes are the identifiers and internal nodes are the operators. Okay, wow. Next is the nodes are always also optionally given a sequence of identifiers for labels that could be attached in the particular node. So the directed acyclic graph, we have two terms. One is the leaf node, other one is the internal nodes. The leaf node represents the operands and the internal node represents the operators. For example, this is the statement. We have to in that statement there is a second and fourth statement are redundant one. So that could be eliminated. That could be find out using the directed acyclic graph. So how to draw the DAG means, for example, in the DAG, we have a operator and operands are the leaf nodes. So first we have to compute the B plus C that could be stored in the A. So B plus C is add that resultant stored in the value of variable of A that could be attached in the operator side. Next is that could next evaluation is the A minus D. So the resultant term is A. that could be minus with the D. So that is the result of that result is stored in B. Next statement, we have the B plus C. Now the value of B is newly calculated. So that could be in the node of second node. So that B is added with the C. C is not newly computed. So that could be reused. That C variable is reused, and we are adding the particular statement that is a B plus C. And finally, we have a minus D. So after the second step, the A and D variable is not computed again. So we can reuse the A and D variable, and we can save the resultant as a D. So that D can be combined in the second statement computation also. So in the minus operator, we have attached the variable of B comma D. So that is the way the directed acyclic graph is constructed. So this is another example of a directed acyclic graph. Same thing that we can convert our 3 address code in the directed acyclic graph, means that could be very easy. In the first statement, the value of A plus B is added and the result is stored in the T naught. Again, the T naught value is added with the C, that could be stored in the T1 in the second step. Next, in the third step, we have the T naught plus T1. The T naught and T1 is already calculated and computed. So we reuse the variable in T naught T1 again. That could be added with the plus, and resultant are stored in the variable B. So this is the another example of directed acyclic graph. In the directed acyclic graph, we have the certain hierarchy. We have the operands, and we do that intermediate. We do the variable sums, and next is the intermediate sum, and finally we have the resultant value. So this is another example of construction of DAG. Now we will see what is the benefits of directed acyclic graph in compiler design. So the first one is it find out the common sub-expressions. That common sub-expression is eliminated using the DAG graph. Next is that dead code elimination. So it removing the unnecessary code that could not be used in the upcoming program. So that red code is identified and that could be eliminated. And next is that algebraic simplification. So the algebraic simplification means we can simplifying the expressions to enhance the enhance the particular computation and also the efficiency. So instead of using the costly function compared with the multiplication and addition, so the addition cost is less compared with the multiplication cost. So that simplification are added in the particular statement. So this is another benefit of DAG. So the benefits of DAG are dead code elimination, common sub-expressions, and algebraic simplification. Thank you.